All right, let's get right into it. Our solar system just had a visitor, a real traveler from that incredible darkness between the stars. It's called 3I Atlas. And it's carrying secrets from a home that's light years away from us.
And really, that's the ultimate question, isn't it? When something travels across that unimaginable distance to show up in our celestial backyard, what kind of story is it telling us about where it came from? You have to understand, these events are mind-bogglingly rare. I mean, before 2017, we'd never confirmed a single one. Then, out of nowhere, Oumuamua showed up. Then Borisov in 2019. And now, 3I Atlas. We are living in a totally new era of astronomy, one where we can finally study material from other star systems, up close.
Okay, so let's properly meet our third confirmed interstellar guest. This is the story of 3I/Atlas, and it's a story that starts out looking pretty familiar, but oh boy, it takes a very, very strange turn.
And there it is. This is 3I/Atlas, first spotted by a survey system whose acronym is ATLAS, hence the name. Now, the really cool part is its path. Astronomers confirmed it's on a hyperbolic trajectory. That's just a sciencey way of saying it's not caught in our sun's gravity. Nope, it's just passing through, a tourist on a cosmic scale.
So when astronomers got their first good look at this thing, what did they see? Did it look, alien, or was it something they recognized? Well, at first it looked just like a comet. It had that fuzzy cloud of gas and dust around it that's called a coma, and as it swung closer to the sun, it started growing a tail. I mean, this is textbook comet behavior, right? It's caused by ices on its surface heating up and turning straight into gas. And just so you know, it was never going to hit us. It passed by at a super safe distance of 240 million kilometers. Of course, anytime one of these interstellar objects shows up, you're going to get some more imaginative ideas. The astronomer Avi Loeb, who's known for thinking outside the box, even speculated that its path looked a little too perfect. Maybe not natural at all, maybe even alien tech. But pretty much the entire scientific community pumped the brakes on that. As Michael Coopers from the European Space Agency put it looks like a comet and it behaves like a comet. There's no reason to think it's something else. And honestly, for a little while there, it seemed like that was pretty much the end of the story. Case closed. And it probably would have been too, except the James Webb Space Telescope, our incredible new eye on the universe, turned its gaze toward our visitor. And what it saw in the comet's chemical signature was, it was anything but ordinary. This is the moment where the story takes a massive plot twist. The data that came back from the JWST sent an absolute shockwave through the planetary science community. Okay, so to get why this was such a big deal, we have to look at the Coma, that fuzzy cloud of gas that's boiling right off the comet's surface. Think of it like this. It's like analyzing the steam coming out of a kettle to figure out what's inside. The Coma tells you exactly what the comet is made of. And here's the bombshell. When the JWST analyzed that Coma, it found it was just packed, absolutely stuffed with carbon dioxide. And I don't mean a little bit. CO2 was the main gas coming off this thing, totally overwhelming the water vapor that we always expect to see. This chart right here really shows you how bonkers that is. It compares the ratio of carbon dioxide to water. See that first bar? That's a typical comet from our solar system. A little CO2, tons of water. Now look at 3I/Atlas. That ratio is about 18 times higher. It's completely off the charts. The actual number they measured was a mixing ratio of 7.6. What that means is, for every single molecule of water vapor, there were more than 7 molecules of carbon dioxide. A number like that has never, ever been seen in a comet at this distance from the sun. So in science speak, this result is 4.5 standard deviations from the norm. To give you some perspective, anything over 3 standard deviations is considered a major discovery. 4.5, that's a statistical earthquake. It means 3I Atlas is fundamentally different from basically every comet we have ever studied. So the next question is pretty obvious. Why? What on Earth or what out there could possibly make a comet so ridiculously rich in carbon dioxide? Well, scientists have a few really fascinating ideas. They're kicking around a few cool possibilities. Could there be some kind of thick crust trapping all the water ice deep inside, so only the CO2 can escape? Or what if it formed in a super, super cold part of its own star system, where it just got packed with CO2 ice from the very beginning? Maybe its journey through deep space for millions of years changed its chemistry? Or maybe it's just made of fundamentally different stuff than our comets.
So what you end up with is this stark contrast. Our comets, which formed out in the Kuiper Belt or the Oort cloud, they're basically water-driven engines. But 3I/Atlas, it's a CO2-driven engine. It's a product of a totally different environment, giving us a peek into a star system that might be way older or chemically different than our own.
And that right there is why this discovery is so huge. This isn't just some weird rock flying by. It's literally a message in a bottle from another star.
It's like Michael Cooper said, these objects are the actual building blocks of other solar systems. When we study them, we're not just looking at a comet. We're reading a postcard from a distant star, learning about the exact conditions where its very own planets were born.
And that's really the big takeaway here. Look, we can't travel to other stars. Not yet. But the universe is sending us free samples. Every single one of these interstellar visitors is a priceless little time capsule, giving us clues to one of the biggest questions we have. Are we a total fluke? Or is the recipe for making planets like Earth common all across the galaxy? When you look at this incredible image from JWST, this plume of dust, you can really feel that connection. I mean, we are analyzing matter in detail that was forged around a completely different star. And with new telescopes coming online all the time, we're expecting to find even more of these visitors, each one adding another piece to the giant puzzle of our place in the cosmos. It just leaves you wondering, right? Oumuamua was a total enigma. Borisov looked surprisingly normal. Atlas looked normal on the outside, but was completely alien on the inside. So what new secrets, what totally new surprises will the next visitor from the stars bring with it?